Database backup and recovery best practices. Introduction. The ability to restore databases from valid backups is a vital part of ensuring business continuity. Backup integrity and restorations are an important piece of the IT governance. In many instances, IT auditors merely confirm whether backups are being performed either to disk or to tape without considering the integrity or viability of the backup media. This video covers the topics related to data loss and the types of database backup and recovery available. Best practices that can assist an auditor in assessing the effectiveness of database backup and recovery are also provided. This video focuses on the technologies and capabilities of the Oracle Relational Database Management System and Microsoft SQL Server because together they cover approximately 40% of all database installations. One of the key responsibilities of a database administrator is to prepare for the possibility of media, hardware, and software failure, as well as to recover databases during a disaster. Should any of these failures occur, the major objective is to ensure that the database is available to users within an acceptable time period, while ensuring that there is no loss of data. DBAs should evaluate their preparedness to respond effectively to such situations by answering the following questions. How confident is a DBA that the data on which the company business depends are backed up successfully and that the data can be recovered from these backups within the permissible time limits per a service level agreement or recovery time objectives as specified in the organization's disaster recovery plan? And the second question is, has the DBA taken measures to draft and test the procedures to protect as well as recover the databases from numerous types of failures? So these are two of the important questions that should be answered by the DBA. The following is a checklist for database backup and recovery procedures that are explained throughout this video. Number one is develop a comprehensive backup plan. Two is perform effective backup management. And three, perform periodic database restore testing. Number four, have backup and recovery SLAs drafted and communicated to all stakeholders. Have the disaster recovery plan or DRP database portion drafted and documented. Keep your knowledge and know-how on database and OS backup and recovery tools up to date. So, developing a comprehensive backup plan. DBAs are responsible for making a comprehensive backup plan for databases for which they are accountable. The backup plan should include all types of RDBMS within the enterprise and should cover the following areas. First is decide what needs to be backed up. It is imperative that the DBA be aware of database and related OS and application components that needed to be backed up, whether via an online backup or an offline code backup. The following are details of what needs to be backed up. Number one is the OS software, the operating system. So an event such as hardware failure will require a complete system restore, starting with the operating system. So there is a need to back up the database server OS initially and after any system updates or configuration changes. RDBMS software. The RDBMS software should be backed up initially and after any patches or upgrades. So next is to decide what needs to be, or this is the continuation rather, that what needs to be backed up. So aside from the OS and the RDBMS, next will be application software where applicable. This applies especially to Oracle e-business suite, Oracle Application Server, and Oracle Enterprise Manager. The application DBA should complete an initial full backup of the applications to this using an appropriate OS command, and then schedule future incremental backups. Example, after any patches or upgrades. This backup should also be transferred to tape. So let's say, for example, also if you're creating an intranet or maybe an internet-based application, so you should know where the files in your application is located, and you should create a backup of these files. Passwords. All super user passwords that may be required during recovery should be preserved. It is a good idea to ensure that the default passwords that came with the initial installation of the RDBMS are changed. Continuation of decide what needs to be backed up. So for Oracle databases, so all components of the Oracle databases should be backed up. And this includes, number one, the database parameter file. It is a parameter file or server parameter file, or it's called SP file, that defines persistent initialization parameters of a database, including information about database control files. Then next is the database control files. The control file stores the status of physical structure of the database. If it becomes unavailable, the database cannot operate. It is imperative that these files be backed up while backing up other components of the database. In later versions of Oracle, so that's 9i onward, the DBA can configure automatic backup of the parameter file as well as the control file to ensure that these get backed up after each backup and after any structural changes in the database. Database data files. Of course, this is very important. This should be backed up during cold backup as well as during online backup using Oracle's Recovery Manager or RMAN, or in Oracle database versions in which RMAN was not introduced, by putting table spaces in backup mode. The DBA should try to run all production databases in archive log mode so that recovery to the point of failure is possible. Redo log files and archive redo logs. So while making a cold backup, the DBA needs to back up redo logs. When the database is running in archive log mode and doing an online backup, the DBA needs to archive redo logs manually or automatically and then back up all archive redo logs. Oracle network files. It is important to back up all Oracle network files initially and after any change. Password files. Password files when used should be backed up initially and after any change. Now, how about for Microsoft SQL Server databases? So we should back up both system and user databases. And we have a separate maintenance plan for system databases. That is for master, model, Microsoft DB. Master supports only full backups. Temp DB backup is not required, and it gets rebuilt during SQL Server backup or startup rather. Backup all user databases. Set up all user databases for full recovery model and back up both database and transaction logs. So these are the things that should be backed up in my Microsoft SQL Server. So aside from also part of the comprehensive plan, so the first is deciding what needs to be backed up. The next one is to determine the appropriate backup type to use for your data. So what will be the appropriate backup type? So for Oracle databases, so logical backups, this type of backup is performed through Oracle Utilities EXP. From version 10G onward, data pump can also be used, and the whole database individual schemas, tables, or table spaces can be backed up. Restore is done using IMP or IMP or data pump. With such backups, recovery to the point of failure is not possible. We can also have the physical, offline, or cold backups. The database must be shut down, and copy must be made of all essential data files and other components of the database. Physical, online, or hot backups. This method enables the database to be backed up while the database is up and running. The following points should be kept in mind while doing online backups. Number one is either put the table spaces in backup mode and back up the associated data files using an OS copy command or use RMAN, a robust tool provided by Oracle for backup and recovery with version 8X onward. Oracle adds new functionality to this tool with each version. RMAN can use the database control file to keep its catalog, or the DBA can set up schema for each database in a separate database for RMAN catalogs. The DBA must review and keep in mind the RMAN compatibility matrix for the database being backed up or restored, as well as the RMAN executable and RMAN catalog database schema. DBAs must familiarize themselves with full incremental and differential backups and set this up using RMAN scripts. DBAs must review their RDBMS edition. Example, incremental backups are not possible in standard editions prior to Oracle 10G. To restore or recover a database to the point of failure or a previous point in time, the DBA must put the database in archive log mode and back up all archive redo logs. It is important not to forget the backup of the RMAN catalog, and at the end of each backup, DBAs can do an export backup of RMAN catalog schema. So how about for SQL Server? So determine the appropriate backup type to use for your data. So what we have discussed in the previous slide was for Oracle. Now it's for SQL Server databases. So logical backups in SQL Server, individual schema objects can be backed up to flat files in any of the supported file formats. Then flat files can be restored using tools such as the BCP utility, the import and export wizard, or the SQL Server integration services tools. Physical backups. It is recommended that all user databases be set up for full recovery model, and both database and transaction logs should be backed up to restore or recover the database to the point of failure. DBA should thoroughly familiarize themselves with database recovery models and full, differential, and transaction log backups and set this up accordingly. File or file group backup strategy can be used if the databases to be backed up are very large databases or VLDBs that are partitioned among multiple files. So the next one is establish a strategy for handling VLDB backups. In Oracle, the DBA can reduce the backup window for VLDBs by allocating multiple channels and fine-tuning backups. Can save this space by using compressed backups and can block tracking with incremental backup techniques with the latest versions. The DBA must review the versions and edition of the database to confirm availability of this option. If this does not do the trick, the DBA can consider setting up split mirror backups. For SQL Server, the DBA can partition the database among multiple files and use the file or file group backup strategy. Also, using multiple backup devices in SQL Server allows backups to be written to all devices in parallel. So, part of the comprehensive backup plan is to establish an appropriate backup schedule and window. It is a good practice to select a backup window at a point when the lowest amount of activity affects the database so that the backup does not reduce available database server resources and slow down the database user's activity. The DBA can tune the backup window by parallelizing backups using multiple channels. However, the DBA must review the version and edition of the database to confirm availability of this option. In the vast majority of cases, it is best to set up a weekly backup cycle starting with full backups on Friday night or Saturday morning and incremental differential backups throughout the weekdays. Archive transaction logs backups can be scheduled for every few hours depending on the volatility of the database. Then next is to decide where to store the backups. So both Oracle and MS SQL Server databases can be backed up directly to tape or disk, locally or over the network. And then the backups can be archived to tape. It is good practice to back up to disk, transfer to tape, and store tapes off-site for disaster recovery. The backups of these are faster. DBAs have more control and can better monitor these, and with this method, DBAs hold two sets of backups, one on disk, the other on tape. During restore, if backups are still on disk, it will be a faster restore, reducing mean time to recover, or that is called the MTTR, the mean time to recover. Then next is to develop a backup retention policy. The backup retention policy relates to both the disk and tape rotation schedule and should be decided upon based on the SLA established with the business user community. The data owner should specify the retention period for the data. The retention period may vary from months to years depending on local laws. Accordingly, the DBA should be deleting old backups to create space for current backups. The data retention policy should be chosen carefully, making sure that it complements the backup media subsystem retention policy and requirements for the backup recovery strategy. If not using a catalog, the DBA must ensure that the control file record keep time instance parameters matches the retention policy. Then, after the comprehensive backup plan, we have the effective backup management. After making a solid backup plan and completing initial work, the DBA should properly manage the DBA should properly manage backups, keeping the following points in mind. Number one is automating backups. For Oracle, either set backups through OAM or use an OS scheduling tool and spool output to a log file that can be reviewed for any errors. In SQL Server, use maintenance plans for scheduling backups. And again, we have a tool in Windows that can be used to schedule tasks. Monitoring backups. Set up monitoring using appropriate tools so that the DBA gets an email or alert through a pager or cell phone or any failed backups, which should be rerun as soon as possible. Backup logs and catalogs. Review backup logs and backup catalog information periodically for any issues. Use RMAN reporting to show backup status. For Oracle, backup the RMAN catalog database by exporting all catalog schemas periodically, as well as by doing an export backup of RMAN catalog schema at the end of each backup. For SQL Server backup system databases, especially master and MSDB. Database catalog maintenance. With Oracle databases, use delete obsolete to remove backups that are outside the organization's retention policy. If obsolete backups are not deleted, the catalog will continue to grow and performance will become an issue. Cross-checking or the cross-check backup will check that the catalog or control file matches the physical backups. Validating backups. Validate and verify backups without doing actual restores. Setting up dependencies. When backing up to this, archive these backups to tape as soon as backup to this completes. The next is the backup restoration testing. So imagine the following scenario. A flood has hit the area in which a company headquarters resides, and the entire IT infrastructure has been damaged, but not destroyed. Before the event, the DBAs perform backups to the backup media, following all of the process noted previously in this article, and had this stored offsite. In the enterprise most recent IT audit, the auditor rated the backup process as effective. The backup media from the offsite storage is retrieved and loaded. Then a message appears on screen that states that the backup media are unreadable due to integrity issues. So what could have happened? So many things could have happened. However, it is clear that a critical step did not happen. The restoration from the backup media was never really tested. So that's a scenario wherein the backup media was never really tested. So the control was marked as effective because a backup process was in place and being performed. In addition, no errors were ever received when the enterprise backup to the backup media. Backups are of no use if the IT team cannot restore the data to the system at the time of need, of course. The DBA should formulate a detailed strategy for this task. So database restore testing. There should be a requirement to test database restores from this as well as from tape backups. Validating restores where possible. The DBA can validate and verify backups without doing actual restores. Validating backups using the restore validate database command will do everything except actually restore the database. So this is the best method to determine if the backup is good and usable before being in a situation in which it becomes critical. Refreshing non-production databases from production backups. So this could also be possible. It is a good practice to periodically build non-production databases from production backups using appropriate backup restore utility commands as a restore practice. Performing annual or biannual restore testing from tape as part of audit. The DBA will have to explain the process through a narrative, preserve logs, and take screenshots to show this type of restore testing. Actual restores. During actual restores, the DBA should back up the database before doing the restore. Depending on the type of loss and backups available, the DBA must decide on whether to go for complete or point in time or incomplete recovery. Incomplete recovery can be time-based, cancel-based, or change-based. Strategy to recover from database corruption. For Oracle databases, the DBA can turn on block checking using appropriate parameters to detect the presence of corrupt blocks in a database. This has a slight performance overhead but will allow early detection of corrupt blocks caused by underlying disk storage system or input-output system problems. By default, RMAN also checks for corrupt blocks during backup. In later versions of Oracle, RMAN can be used to repair corrupt blocks in the database. Backup and Recovery SLA. The DBA team must draft a backup and recovery SLA, covering details of backup procedure and including a timeline for recovery and have management sign off on it. The SLA does not assist in the recovery process itself, but sets the user community and management expectations for the recovery process, which may provide the team more time to complete the restore process. Then the next is there should be a disaster recovery plan. The DBA should take care to ensure that databases are included as a key element in the company's overall DRP. All stakeholders need to understand the elements of the recovery plan and in what order the IT team will restore the databases. The business must provide its input at this stage so that the most business critical applications are available as soon as possible. Database and OS backup and recovery tools. It seems obvious, but DBAs played the final and most important role in the process in that they must keep their knowledge of backup and recovery tools for RDBMS up to date. During the actual restore event, DBAs will not have time to figure out any advancements in backup and recovery tools. As a conclusion, the primary responsibility of the database administration team is to review all types of RDBMS in the enterprise and to develop a comprehensive backup plan to conduct effective backup management by proactively monitoring backups, getting alerted for failed backups, and rerunning these seamlessly without loss of time. It is good practice to back up data to physical disks and to then archive the data to tape for disaster recovery purposes. Once an approach has been established, it is imperative to test data restoration periodically as part of the backup and restore strategy, and to review all options before executing the actual restoration recovery. It is important to confirm that the DBA team is abreast of the latest backup and recovery tools and to ensure that the team has a clearly documented process in place with clear responsibilities. If DBAs maintain proper backups, monitor this proactively, and can provide assurance of the recovery of data to the point required by the business, they have done a major part of the job for which they were hired. IT auditors can assist data administration teams in strengthening their controls and data recovery process by validating the DBA operations, including the testing of the recovery data. This continuous proactive and cooperative effort between the internal audit and the DBA team can provide assurance to management that in the event of a disaster, the business data can be recovered. So this ends this video. So thank you very much for listening.